Hello, this is Jeremy, and I'm going to go through with you how to make a histogram using data if you're going to make one by hand. Now, it's important to realize that nobody really does this outside of a statistics course. So you may ask yourself, why am I bothering to show you at all? Well, I think that going through it by hand once helps you understand the graph itself and how to read it and everything. Well, to make a histogram, the first thing you have to do is make a frequency distribution if you're going to do it by hand. Now, software can jump straight to a histogram, which is pretty nice. And before you can make a frequency distribution, you have to decide how many groups you're going to have in your data set. Now remember, the idea is to see the big picture. A lot of times 6 groups is pretty good, and there's rules of thumb and other ways to figure this out. We're going to use 6 groups to represent the salary data. So in other words, I want to use 6 classes. So the first thing that I need to do is decide, well, if I want 6 classes, then how am I going to break up the data? So I'm going to take the smallest data point and the largest data point and subtract them, and then divide by this 6 to decide, okay, how would this work out? And whatever I get, I'm going to end up rounding up just to keep the numbers nice, because no matter what, in the end, there isn't one scientific method to make the perfect histogram. What you're trying to do is make something that people can read and read easily. And 7.3, that's fine, but it's much easier to use something like 8. So a lot of times people round up because it keeps the counting clean. It keeps the groups the way you want them. If you round down, you may actually affect the way the groups come out. But again, this is something software typically takes care for us. So, okay, I want to have these classes or groups. And then what I'm recording in my frequency distribution, which I'm setting up here, is the frequency F. All right, so starting with my smallest, I'm going to go 24. And then this says I should go 8 across. So I'm going to add 8 to 24, so I'm going to get 32. So I'm going to count how many points are between 24 and 32 here. Now, 32 is going to start the next group. I'll explain that in a minute. And then I'm going to go up 8 to 40. I'm going to continue this process, so 40 to 48. So I'm grouping up my data. 48 to 56. 56, remember you're adding 8 each time to 64. And 64 to 72. So again, the big idea, group up the data so you can see general patterns. And so when you do this in software, what it does is it just often uses one of those rules of thumb to calculate what the perfect number of groups is, but then we tend to adjust it. So it does this in the background. Now the next step is to figure out how many numbers are between 24 and 32. The problem is, well, what if we have 32? Where does it go? Well, in this right-hand endpoint, you're never going to include this right-hand endpoint. So this will be 24 up to 32, 32 up to 40, 40 up to 48. And so when you see this in a histogram, remember, it's not usually including that right-hand endpoint. So 24 up to 32, not including 32, would be all these numbers right here. So I see 1, 2, 3, 4, 5, 6, 7. Okay, so frequency of 7. All right, so that's not too bad, right? Now 32 to 40, not including 40. 1, 2, 3, 4, 5, 6, 7. Okay, not including 40, right? 40 goes in the next group. 40 up to 48, not including 48. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 48 to 56, not including 56. 1, 2, 2. Yeah, 2. 56 up to 64, not including 64. 1, 2, 3, 4. And then 64 to 72, not including the 72. 1, 2, 3, 4 as well. Now I want you to notice 2 things about that process. First of all, it was pretty tedious. This is a small data set. I think if I remember correctly, this has 32 numbers in it. And it still took a little bit. It also is open to a lot of error, right? I mean, I could have miscounted very easily anywhere just because counting's easy and it's easy to not pay attention. This data set's already in order. And when I just glance at the data set, it's hard to see a pattern. That's the whole point of making a histogram. Now take this to a bigger scale. Change it to where you have 10,000 points in your data set. They're not in order. You can see why we use computers, right? Now, one quick way I could use to check this is I know there's 32 data points here, so I can see if my frequencies add up to 32. So 8 and 2 is 10, 4 and 4 is 8, so we would have 18. 18 and 14 would be 32, right? 18 and 14 would be 32. So this should match up. The total frequency should match up. That doesn't guarantee I didn't make a mistake, but it's a very good check. So this right here is what your textbook refers to as a frequency distribution. You know, you don't see these too often anymore because we use software, like I mentioned a million times. All right, so how does this translate to a histogram? So we'll hand draw this. And a histogram will have the frequency as the scale over here. So frequency, and down here, it'll typically have your groups or classes, but it'll list what they are. So we would say salaries in thousands. And then as a title for our graph, we could say salaries at a small company. Okay, now we want to take our classes down here, and we're going to be making essentially what looks like a bar chart, although it's quite different from a bar chart. So 24, 32, then we go up to 40, and then 48. Make sure you see where these are coming from. 56, 64, and then 72. And so that's going to be your scale here. And then looking at the frequencies, the tallest we have is 8. So honestly, we could probably count by twos. 2, 4, 6, 8, and I could probably have done better, right, with the scale, but just for example, we'll leave it as it is. And so the first two groups have frequencies of 7. So what happens with a histogram is the bars essentially sit on the class width here. So we're going to go up to 7 with our bar for each of these two groups. Okay, and then the next group had a frequency of 8, so that goes up to 8. The next group had a frequency of 2. Next group had a frequency of 4. The next group has a frequency of 4. So this would be a histogram. Not an amazing histogram. It doesn't seem like I can draw a straight line at all, right? But in the end, this is an example of a histogram. So what did this do for us? Well, this allows us to see patterns now. I can immediately see that most of the employees make less than $48,000 a year. You can just look at this and tell. And later on, we'll also talk about the idea of shape, center, and spread, which are big, important ideas with data. Now, one thing I can't tell you, though, is how many people made $35,000, if any. I can't look at the histogram and tell you that. All it gives me is the big pattern. So we'll explore that quite a bit more. And I hope that going through this process of actually doing this by hand helps you see how the data is put together in the histograms. But like I said, from now on, the main thing we're going to look at is how to read these and how to get information from them and how they're helpful in understanding data sets.